So, hello everybody. My name is Sebastian JORDAN MONTAño. I'm going to present PharoAI. Well, also this is a work of both me and Oleksandr. Hi, Olex, that guy over there. But it's me who is going to give the presentation. Okay, so yes, so this is the... Okay. So, I'm going to introduce you PharoAI version 0.8. That is a modular library for doing shallow machine learning in Pharo. We are going to explain later what is shallow machine learning. And we want to focus on the point of modular because, well, it's a modular library. That means that you can load like specific algorithms, a specific part of it, or also you can download everything. And also, of course, if we develop in a modular way, it's more easy to test, and of course, like we are good Pharo developers, we like to write a lot of tests. So, I'm going to start with a little theoretical explanation, or like big picture of what is artificial intelligence or machine learning, because there are like two like mixed up terms. But so, in artificial intelligence, in a big way, is like the ensemble of techniques that enables machine to mimic human behavior. Like, for example, there is star algorithms or machine knowledge-based algorithms. And machine learning is a specific subset of artificial intelligence that use a method or functions of statistics that enable machines to improve over time with experience. For example, you have like linear regression, k-means, naive bayes, and almost like the vast majority of algorithms that are available. And also you have, for like last, you have a deep learning. There is a subset of machine learning that uses deep neural networks that are statistical or mathematical function, but in a specific way. And like, for example, you have the well-known like convolutional networks of deep networks, so on. In our machine learning library, we have two types of algorithms, supervised and unsupervised. So the first set is supervised algorithms that they require, for example, label data. They require that the data is already labeled. In order to learn for the examples, the algorithm learns for the example, and as it has labels, it can like calculate if it's predicting wrong or bad, like bad of wrong, good of and bad. Sorry, and then it's going to apply that knowledge to new data. For example, you have like classification of regression. And unsupervised data actually is the vast majority of the data that is available on the internet is unsupervised, that has no label. So what it does is extracts patterns from the data and apply the knowledge of the patterns to the new data. So these are the two, like this is the shallow machine learning that we have available in our library. So like one question that people ask is, why do we need machine learning library in Pharo? Well, first, we want to, as you already know, Pharo is a great language to teach. It's like super good to teach. So we want to provide the machine learning expertise and to teach the machine learning to Pharo community people that are interested in machine learning, or maybe they do machine learning, or maybe they want to enter into the machine learning world. So like it's like with teaching purpose, but also we want to get involved in the current work that is being done by the Pharo community all over the world in machine learning. For example, you have work in the University of Chile with object profile. They use like neural networks, deep networks. Also, there is Polymath for scientific and mathematical computations. There is semantics in Bolivia that they have genetic algorithms. There is in France. And there is a Buenos Aires Smalltalk group that they also do machine learning things. So how do we position ourselves? So we did this table like with the two well-known programming languages that they are using machine learning, like Python and R. And for example, for data analysis and manipulation, there is pandas in Python, there is Dataframe in R, but we also have Dataframe in Pharo. For algebra, you have NumPy, you have SciPy, you have math, you have SparseAm in R, but you also have a Polymath in Pharo. And for shallow machine learning, we have like PharoAI, this is us. It's like we can see like as an equivalent of scikit-learn in Python, for example, or machine learning in R. Also, for deep learning, there is like a TensorFlow that is a C library. So there's like a binding for Pharo, binding for Python also. That is the same library. And for data visualization, we have Rosa. That we are going to have also Milton's presentation, I think tomorrow. But also like there is Matplotlib and Gplot. So this is part of the AI machine learning ecosystem that we have in Pharo. Like these are the normal workflow when people do data science or machine learning, like having like data analysis, manipulation, visualizations, machine learning, and so on. So now I'm going to show you a little bit of the available algorithms and library that we have in our Pharo-AI ecosystem. And as I mentioned before, this is not only our work, this is also work of the Pharo community as a together. So for the first part, for the scientific computation / like math or statistics, first we have Polymath. That is like our most big library that for doing like pretty much a math. There is stats, there is also a little bit of differential equations and so on. We also have a library that is metrics, that is specifically for calculating, for measuring the metrics, the performance of the machine learning algorithms. Also, we have a fast linear algebra. We call fast because actually this is a binding for Lapak. For those that you don't know Lapak is a Fortran library for doing linear algebra. So we have a binding in Pharo that actually computes in Lapak. So this is like pretty fast because actually it's in Fortran. Also, we have edit distances that is like a package also for calculating distance between strings or between the two, pretty much strings. And also we have a principal component analysis that is like a few words. You have like a big data set that maybe you have like hundreds of features. You want to summarize, or you want to get the most important or the most meaningful features of the data set. So the principal component analysis gives you that, like it gives like a summary and like a number of, it takes, for example, 100 features and gives you a resume of 5 or 3 of the most important ones. Also for data manipulation, we have Dataframe. That is kind of a pandas. We have a data sets in that we can manipulate them, we can merge them, we can join them, etc. We have data normalization to normalize the range of the data that we have. Also, we have a random data generator that for generating random data, for generating also random data sets. Also, we have like a data sets library. This library contains like the most known data sets, like for easily loading. We have like, for example, Iris or etc. So we can like, instead of copying the CSV, is already available in Pharo. And for clustering, we have K-means, we have K-nearest neighborhoods, hierarchical clustering or Gaussian mixture models. Actually, clustering is a technique of unsupervised machine learning that you have like unlabeled data and automatically detects like groups of data. And these are different algorithms for doing that. And for regression, we have logistic and linear regression, and also we have support vector machines. And as you have here in the legend, the ones in green are the ones that are ready to be used, and the yellow ones are the ones that are currently being developed and that are work in progress. Also we have like libraries for natural language processing. We have like a list of stop words. Stop words, for the ones that you don't know, are the words that are normally you can omit. For example, like the articles in English, the or of, in. So normally those words that they don't add too much meaning of the sentence, but they are present a lot. For example, the article the in English is like present a lot, so normally that doesn't add meaning. Also, we have n-gram models. We have TF-IDF, that is a technique for encoding words into vectors of numbers. And also we have a spelling corrector project that is like a project of Oleksandr that also allows you to detect automatically a language. You have a text and it gives you the probability this text maybe is English, French, Spanish. Also we have classification algorithms that we have like a random forest, we have decision trees, we have the naive-based classifiers that these actually there are different algorithms for classifying data in a binary way. Is that the way that we implemented? We have maybe in a true or false. For example, someone has cancer, yes or not. Also, we have a binding of OpenAI. OpenAI is a library of artificial intelligence. This is work of the Buenos Aires Smalltalk group. And actually, this was about to be ready to be released, but then suddenly OpenAI, they released a new version of the library in which they deprecate almost all of the API. So, okay, so we need this. Our version, it was like outdated, like from day to another. You have a question?
So, classification, are you re-implementing those algorithms from scratch, or you are using already implemented version from some other library?
No, yeah, all the algorithms that we have is we are implemented. Sorry. She asked if we are implementing the algorithms or if we are using other implementations. And to answer the question, all the algorithms that I show is the algorithms that we implemented in Pharo, purely in Pharo from scratch. Yes, from scratch. Also, we have a collection of graph algorithms that we have like 15 of the most known graph algorithms. For example, we have Dijkstra, Kruskal, Tarjan, etc. for doing graph analysis. And also we have the a priori algorithm for doing data mining. And here you can see like an ensemble of the algorithms that we have. Of course, we have other little things, but this is like the most important things that we have. So as you can see, like the majority are like ready to be used. We are like work in progress. Well, all the algorithms, they are work in progress, no? But these are the ones that they need some touches to be like in a stable, ready to be used version. We also have, as I told before, Dataframe is a library that we have for doing data manipulation and analysis. And for example, if you have a Dataframe object and you inspect it in Pharo, it calculates automatically, for example, some stats here. You can see you have some stats, for example, well, maybe it's not readable, but you have, for example, the first quartile, the second one, the median, the medium, the variance, the mode, and the average of the data set. Also, we have some important data like the dimension of the data. We have some like a view of the columns of the data frame. And of course, we have the evaluator of the inspector that we can evaluate things because, of course, this is an object and we have access to the object. And also we have a visualization of the data frame. This is, for example, a screenshot of the iris data set that is like a simple data set. And all of this is generated automatically. So you have the data frame object, you inspect it, and you have these like visualizations or these tables. And well, we also have like, this is a collection of the other machine learning projects available in Pharo. There is like a very big list of all the things that Pharo community are doing that are related to machine learning or artificial intelligence. We provide, or mathematics, and like, these are links. And finally, we have the PharoAI wiki. Maybe I will show you like super quickly. Yeah, for example, but we have here the wiki that, for example, we have documented pretty much all the things that we have. We have some tutorials that are written. And so if you want to start using our library, this is the best place to start. Okay, now I am going to talk about a benchmark that we did. One question that we often hear is like, why are you doing machine learning in Pharo? Because there is already like, there is like a Python, there is R, there are super fast, and why do we need something in Pharo as they have the same in Python that is faster? But actually, there is nothing in a technical point of view that stops us for being as fast as the industrial state-of-the-art libraries. So here we wanted to, with Olex, we did a proof of context that there is nothing to stop us to actually to reach that speed. So we did a benchmark of an implementation of the linear regression algorithm that we did. Like we did like two versions, one in a pure Pharo, and other one with, so for example, we took a scikit-learn that is like one of the most used framework for doing machine learning, and actually they are pretty fast. But they are fast because they do the most important math calculations using SciPy in the case of linear regression, and actually SciPy uses Lapak Fortran. So they are fast, but not because of Python by itself is fast, that because they delegate the heavy math computations to Fortran and to C. So we want to show a proof of concept that in PharoAI we can have like a similar workflow using Polymath, using Lapak, and using Pharo. This is not the current state of like that we did. We did like directly PharoAI to Lapak, but the next work is to, instead of doing from PharoAI to Lapak, we want to use Polymath, and we want to speed up Polymath. That Polymath can be very fast. And like that also, Polymath is like a more general purpose use in the terms of mathematics because you can do mathematics but not related machine learning work. So we did the benchmark with the, So we did two implementations of linear regression algorithm. One in pure Pharo without delegating anything to Lapak, and other implementation is delegating the most important math computations to Lapak in Fortran. And in order to do the benchmarks, in the technical details of the experiments, we are going to spend in the IWST explanation. So now I'm not going to talk about technical, only about the results that we have. But for do the benchmark, we use 3 datasets. One is small, that is like 82 megabytes in size with 200,000 columns and 20 rows. That is a stable number. A medium one with 1 million and a large one with 5 millions. So we see that we increase the order of the datasets by 5 each times in the columns. So the first number that we have is that Pharo and Lapak is up to 8 to 5 times slower than scikit-learn. That's because this is normal, because scikit-learn is like a state-of-the-art library that has a lot of like a state-of-the-art optimizations. And as you can see, this is like also good. For the small and the medium data set, we are 8 times more slow, or scikit-learn is 8 times more fast. But for the big data set or the large data set, we are only 5 times more slow. Also, we did a comparison between pure Pharo versus pure Python. We also rewrote exactly the same algorithm in Python and in Pharo with the same test. We really tried also to make it as exactly the one in the one in Pharo and the one in Python. And we see that actually Pharo is 5 to 15 times faster than pure Python. And we have some hypotheses to that. First is that Pharo has the JIT compiler, just-in-time compiler. As pure Python, they don't have that. So for example, this is for the medium data set. So this is the data set that is big. So as it start running and running and running, Pharo starts to detect the hot method. So it compiles that method that as you can see, is increase the speed of Pharo. So, but that is an hypothesis. We need that is a further investigation to be confirmed. And also, we did a comparison of a pure Pharo algorithm versus Pharo and Lapak. And this is logarithmic scale because the numbers are too big to be shown. But as you can see, we increase our runtime speed by 2,000 times. So, for example, in the algorithm in pure Pharo, for the medium data set, it takes 2.9 seconds to be executed. And the other one, it takes 1 hour and 45 minutes. So like this is a pretty big difference between 2 seconds and almost 2 hours. And for the small data set, in the Pharo plus Lapak, it takes 0.6 seconds, and the other one, it takes 19 minutes. So also this is like an amazing result that we have that say, okay, like we improve the speed in Pharo a lot, only by delegating the math computations to Fortran, to a Fortran library. Of course, in scikit-learn, they don't only use Fortran. They also have like C files that they rate them to like, and also, for example, there is a process of the manipulation of the data that is also highly optimized because our library, the data frame that is like for data manipulation is also not optimized. Sorry, yeah.
Will Lapak use multi-core versus Smalltalk or Pharo here that just uses a single CPU?
Well, that is a good question. And, sorry. Casper asked if Lapak uses multi-core and if Pharo doesn't use multi-core. Well, Pharo only uses one processor, that is for sure. And Lapak, it has support for multi-thread, but in the implementation that we did, we didn't use the multi-thread core. So, well, as you can see, this is like the last good result that we have. Like, and to show, yes, of course, we are still slower than scikit-learn, which is, of course, normal, but there is no technical reason to not be as fast or maybe faster than them. And well, this is, if you want to visit us, as I show you, the wiki is the best place to start. It has like a getting started page, the documentation on how to install the library, and most of the algorithms that I show you, they have a wiki page, or if they don't have, the wiki page is going to be written. Well, questions? Yes.
So what's standing between you being as fast or faster than scikit-learn, and is that something that you are working on? Because I would love to have some of my colleagues using Pharo for doing their AI applications, but those numbers are not going to increase.
Yeah. So the question is, what is blocking us to be as fast as scikit-learn? So there is a lot of reasons, but in the first is we did this benchmark only for the linear regression algorithm and only actually for one case of linear regression. So first of all, scikit-learn is like a huge library that has like a lot of people working on it. It has like 15 years like of being developed. So our goal is not to compete to scikit-learn. Our goal is not to be the next scikit-learn or to make Pharo like the state-of-the-art machine learning library. It's more to teach and to show that it's possible to do these things with Pharo. And to see and to reply to the question, well, there is a lot of things. For example, each of the algorithms has like a mathematical restriction, so you cannot use Lapak for all the algorithms, for example, only for the ones that you can solve using linear algebra. If you, for example, if you other approaches, for example, gradient descent, that is like an iterative process, you cannot use Lapak for that. What scikit-learn did for that is they wrote some mathematical functions in C, and they have the C file in the repository because it's open source. So, and also, for example, in the data manipulation, because, for example, you have like a gigabytes in data set, they also use pandas or they also use NumPy. That is also highly optimized because they use C, and we don't do that. So it's in order to be as fast or closer as them, we need to treat each of the algorithms individually. And in scikit-learn, they have more than 150 algorithms. So we need to optimize each of them, and we need to make a study of each of them, and we don't have as many resources, and also we are not focalized in machine learning as them.
Did you apply for these libraries for object recognition or character recognition in pictures?
We have one project of character recognition that is not working super good, but yes, we make also like a proof of concept that yes, we can apply to that. Yes, we have also some work for image segmentation, for example. Actually, we are going to show that on Wednesday of the workshop because we are also going to do a workshop.
There was an application of the neural networks in Pharo for the recognition of handwritten digits, and it gave something like 95% precision, which was not as good as the state-of-the-art techniques, but it was, as good as the most simple implementation, for example, in scikit-learn.
Yeah, Oleg said that there was an implementation of neural networks for doing character recognition, and it has 96% of accuracy. There are questions, more questions?
I would just like to add something. So I would just like to add to this question that you have asked. So what was stopping us from being as fast as scikit? So in fact, they do many different optimizations in scikit-learn. So they optimize the data structure that they use. They have a very nice implementation where part of the data structure is located in C, and like this they make it super fast. Another thing is that they optimize the algorithms through Fortran, through these Lapak things that we showed. So for now, we focus only on the implementation of the algorithm. But there is also the optimization of the data structure. And this is something we will do in the future work. But also to connect the question of Deepa, because Deepa asked if we re-implement all these algorithms. So in fact, what we would like to do is to keep as much code as possible in Pharo, because this allows us to debug, to inspect, to understand this code. And then the parts that make it slow, so we delegate it to other languages when they have a super, super crazy optimized implementations. So that's what they wanted to add.
Well,
But those languages are going to be something low level like C or Zig or something like that, not Python.
Yes, indeed.
sorry, the question was if this optimization is going to be in low-level libraries like C and Fortran, and yes.
Yes, indeed. So when we look at these low-level, high-level libraries, like in Pharo, in Python, in R, or now in Pharo, so all the low-level computations, they usually happen in other languages. So, and these are libraries that were developed in the 80s. They were super nice, super good, and now they're used by, for example, by Python or by R. So we want to use the same. We want to do the same thing. We would like to have the polymath that references all these libraries and calls these very optimized algorithms, and then we can do the high-level machine learning stuff in pure Pharo.
But you should see that in Python they use Cython, and Cython this is not Python. This is just a C.
Yeah, it's the kind of Python that compiles into C and then it's C.
Yeah.
Thank you.
Thank you.